Alright, a function, generally speaking, is anything that could take an input. So I could take an input. An input is described as the x variable and will give you one and only one output. If it gives you two outputs, it's not a function. So, output. So what does this mean when I say gives you only one output? So let's say we have a graph right here. We have a graph that is a rough sketch, and we have a point right here. So we're given this graph, and at this point 2 right here, this is the input, as the input is represented as the x variable. So I'll put this as x, y. So say if it says f as 2, that is terribly drawn, f as 2, you should only get one output, right? So right here, I'll change the color right here. You have f right here as 2 and f right here as 2. So let's say this is 1 and this is 3. So right here, f is equal to 1 and 3. So you can only have one output. So this is not a function. Alright. Generally speaking, functions are usually in functional notation, which is f of x. F of x, which x is equal to the output, as the input, as I said, and usually you would have an equation as y is equal to, let's say, mx plus b as a linear term. F of x is simply the same thing as y, because if you think about it, when you isolate something for f of x, so you have, I'll give you an example right here. So you have f of x is equal to 2x plus 2. This is still a linear term, and it says solve for when f of x is, solve for when x is equal to 2. So you have 2 times 2 is 4. 4 plus 2 is 6. As you can see right here, it's saying this. What does this mean? It says that when the variable, when the x is at 2, you have the y at 6. So this basically means you are solving for the y variable. So if the 6 is the y variable, that means f of x is basically the y variable. Alright, so what I will be doing in this video is, first I will be going through the vertical line test. Oops, forgot an E. And then second, I will be showing you some functional notation. Which is simply this, mostly. Functional notation. This means replacing what we usually use as y, replacing it by f of x. This is usually done in functions, introduced in functions, and yeah, I'll be going through the vertical line test, which is seeing if a function is a function or if it is not a function. Alright, I'll move on to the vertical line test first. The first one, I'll name this the second, and I'll name this the third. Alright, so the whole point of a vertical line test is to see if you, when you are given a graph, to see if it is a function. I'll represent this by check mark, or if it is not, I'll represent this by not an x variable, just an x. Alright, so let's start off with the first one. The vertical line test simply means that you will put a vertical line anywhere in the graph, and I like making it dotted line just so it shows that this is not actually part of the graph. So once you have this dotted line, you're going to see, when does it hit the actual graph? It hits the graph right here at one time only, right? It's the graph right here at one time only. Right here, it hits the actual, it hits the polynomial. This, I just draw a rough sketch, but it looks like x to the power of 3 as a polynomial, so it hits it once. If it hits it once, that means it is a function. If it hits it twice if it hits it once, it is a function. If it hits it twice or more, it is not a function. Alright, let's move on to the second one. This one I attempted to draw x squared just off the top of my head, as I know what it looks like. So let's put it right here, and let's make it a dotted line. So let's go right here. Alright, so looking at the line, you can see that it hits the line right here. It's the line right here once. So it hits it once, so that means it is a function. So now you know quadratics are functions. You know polynomial functions are functions, no pun intended. And now let's move on to the last one. The last one is a little weird graph that maybe you wouldn't see every day. And let's put a line right through it right here. Put a vertical line right here, and now let's make it a dotted line, just like all the other ones. Let's make it a dotted line. And now we can see that it hits the graph. Hits the graph here. That's the eraser. Hits the graph here once, right here, and hits the graph here once. So that means if it hits it twice, that means it's not a function. This is not a function. The third graph is not a function. So what does this mean? As I said in the beginning of the video, f of x A function is something that can take an input and will only give you one output. So right here, let's say right here, this x is at 2. This x is at 2. So when x is at 2, it gives you two outputs. It gives you an output right here, let's say this is 3, and it gives you output right here, let's say this is 1. So if f is at 2, it could give you 1 and 3, which that means it is not a function. Alright, now I'm going to move on to some functional notation and showing you if a question tells you f of x solve for when x is at a certain number or a unit. Alright, so let's say you have f of x is equal to, I'll use a quadratic term, x squared plus 5x plus 10, let's say that. And let's say the question says solve for f of x when x is equal to 2. Alright, so what you would simply do is you put f, instead of x you'd put 2, just to signify that you are replacing x with 2. This is good communication skills. So let's substitute everything as 2. So 2 squared plus 5 times 2 plus 10. The constant term doesn't have an x, so you wouldn't change that. So now you put f of 2 is equal to 2 squared, which is 4, plus 5 times 2, which is 10, plus 10. And then you put f of 2 is equal to 10 plus 10 plus 4, which will give you 24. Alright, so what does this tell you really? It tells you on this graph. Let's put a graph right here, as functions are usually drawn in graphs. Excuse me. So this tells you that when you have when you have x as 2, I'll put an x right here to signify that is the x-axis and y right there. So it says when you have x at 2, y will be at 24. So drawing a line right here, that means the point will be right there. So let's say as it's a positive quadratic, it will look like something like that kind of. Or it may differ because we don't know if this is the vertex or not. Alright, so let's move on to another example question. Let me clear out this graph. Another example question, and this time I'll use a linear term, possibly. Yeah. Alright, so let's say we have f of x is equal to, let's just say 2x plus 3, and we say the question says solve for when x is equal to 7. Alright, so we would write out the same equation, and now we would substitute all the x terms as 7. So 2, we only have one x term as it is a linear term, it's just a straight line. So we would write x as 7, and then we write plus 3, and now we would continue on and solve for these equations. So 2 times 7 is 14, 14 plus 3 is 17. So we know, what does this tell you? Let me go back to the graph right here. Let me just get rid of that. This tells you that when x is at 7, let's put 7 right here. That means the y variable, the y will be at 17. Let's put 17 right here. So we know that when x is at 7, y is at 17, and then we could just draw a line right through that, and that could be our answer right here. As it is a linear term, it continues going on to infinity. The domain would be x element of r, and the range would be y element of r. Alright, so this was some background information and some introduction to functions. What a function is, something to take from this video is that a function is anything. It could be multiple things. It can't just be there's a variety. Functions is just a word that could describe mathematics, but it could also be some things out of mathematics also. So function is anything that could take one input and can only give you one output, not two outputs, not three outputs, not four. Alright, thank you for watching.